536. That's how many cloud job descriptions that I analyzed for this video that you're watching. After going through every single one, I can tell you with absolute confidence what most people are learning to become a cloud engineer and what companies are actually hiring for in 2026. Those two are completely different things. The industry loves giving you a checklist. Get this cert, learn this tool, watch this tutorial. But when you look at what's actually written in the job descriptions, the picture is much more nuanced than you think. Companies don't just want a checklist cloud engineer. They want someone who's well-rounded, who understands why things are built in a certain way, and who can actually operate and work in a real production-like environment. Hi, I'm Suleiman. I've worked in tech for more than a decade, and my journey started all the way back in 2015 when I was just earning $18,000 a year as a technology apprentice. From there, I managed to work my way up to earning multiple six figures in tech, and now I'm running my own businesses across cloud and AI consulting, software, and my education company where I've helped more than 900 IT professionals, engineers, and career switchers master cloud and AI. Now, in this video, I'll reveal the most in-demand skills that showed up in virtually every single job listing, and I'll explain to you what each one means and why companies even care about them. And for a little bonus for you, if you stick around to the end, I'll share the honorable mentions that just missed the cut but will give you a serious edge and advantage when it comes to interviews. Now, quick note before we dive in, the analysis is specifically for cloud engineer roles. That said, the skills translate incredibly well into DevOps, SRE, and platform engineering roles as well. So let's start with number one, infrastructure as code. Now, this showed up in every single cloud job description. And honestly, it should be no surprise. Infrastructure as code, or IAC, is a single most in-demand skill for cloud engineers right now. But what is it? In simple terms, it's a difference between clicking around a console to build your infrastructure and writing it all as code. Now, before infrastructure as code, you'd log into the AWS console, manually configure servers, database, networking, all through the UI, right? The graphical interface. That works completely fine when you've got one or two servers. But what happens when you've got 50? What happens when something breaks at 2 a.m. and you need to rebuild the entire cloud environment in a different region? You won't be able to remember every setting that you clicked, all right? You can't reliably recreate it. And you certainly can't hand that off to another engineer to create the environment for you. That's the problem that infrastructure as code solves. You write your entire infrastructure in template files, your servers, your networking, your security rules, your databases, all defined as code. You store it in version control, which is basically a system that tracks every change. Think of it like Google Docs version history, but for code. And then you run one command and your infrastructure stands up exactly the same way every single time. Same configuration, same settings, completely repeatable. That's incredibly powerful, and that's why companies want it. Now, Terraform dominated the cloud job listings, and the reason is pretty straightforward. Terraform is cloud agnostic, which means that you can use Terraform with AWS, Azure, and GCP, and it doesn't really matter. You write simple configuration files describing what you want. For example, I need a server here, a database there, and this network setup. You run a couple of commands, and then Terraform builds all of it for you. No clicking, no console, all just code. AWS CloudFormation also came up. CloudFormation is AWS's own native infrastructure as code tool. If a company is fully committed to AWS, CloudFormation integrates tightly with every single service and handles a lot of the behind-the-scenes tracking automatically. The key thing to understand here isn't just the tool, right? It's the concept. Why does infrastructure as code matter from an operational and disaster recovery perspective? If you can explain that clearly in an interview, you're already ahead of most candidates. And one more thing worth knowing, the infrastructure as code space is evolving. There's a growing shift towards what's being called infrastructure as APIs. Now, instead of writing a giant Terraform template every single time, you define a cloud resource once, and then developers can just request it on demand, just like calling an API. Tools like Crossplane takes this even further. You can create cloud resources directly through Kubernetes, and Pulumi lets you write infrastructure as code using programming languages you already know, like Python or TypeScript, instead of a separate configuration language. Now, obviously, you can also do that with AWS CDK, but don't worry about that for now. You don't need to learn all of these, right? Terraform is still the gold standard, but it's worth knowing the direction of travel is towards infrastructure that's more dynamic, more modular, and more programmable. And if you have a solid Terraform foundation, picking up these newer tools later becomes so much easier. Number two, CI/CD pipelines. This leans more towards the DevOps side, but CI/CD showed up consistently across cloud engineer job descriptions. And the reason is simple. You are building the infrastructure that applications run on, the servers, the networking, the databases. So understanding how code actually gets from a developer's laptop all the way into that infrastructure is genuinely important. So what is CI/CD? CI stands for continuous integration. Every time a developer saves their code and pushes it to a shared repository, think of that like a shared folder where the whole team's code lives, right? It automatically kicks off a process. That process builds the application and runs tests to make sure nothing is broken. So you catch problems early, before they even reach real users. CD stands for continuous delivery or continuous deployment. Once the tests pass, the application gets packaged up and shipped to a live environment where real users can access it. And that can happen automatically or with someone clicking an approval button first. So it's gated. You absolutely need to understand how pipelines work and how they connect to infrastructure that you're managing. Now, in terms of tools, here we've got GitHub Actions and Jenkins. Those were the two that came up in most of the cloud job listings. GitHub Actions is lightweight. It lives directly inside of your code repository in GitHub and is incredibly popular for newer projects and startups. Jenkins has been around for years. It's highly customizable and a lot of big enterprises still run their entire deployment pipeline through it. GitLab CI also has a fair number of mentions too. Now, one thing that I want to clarify because I see this confusion all the time, Ansible is not a CI/CD tool. CI/CD tools like Jenkins handle the pipeline, the journey of getting code built, tested, and deployed. Ansible handles what happens on the servers themselves, right? So making sure that they're configured correctly, the right software is installed, the right settings are in place. They work together, but they do completely different jobs. And speaking of jobs, if you want my help to land a six-figure cloud engineering job, just like I've helped all of these people, including Mac and John, who landed roles at AWS, and just last week, in fact, 2 more of my students got their first cloud roles. If you're serious about making the transition to cloud engineering and landing a role, all you got to do is check the first link in the description. Number 3, scripting and automation. This one is a non-negotiable. If you can't work in the terminal, you will struggle as a cloud engineer. And there are really 3 layers here that you need to think about. First is Linux and Bash. The cloud runs on Linux servers, and the majority of the servers that you work with, the majority of containers that you deploy, they're running on some flavor of Linux under the hood. If you can't navigate a terminal, check logs, manage files, troubleshoot a process, or write a basic shell script, you are going to hit a wall. Now, if you're not familiar, a terminal is basically a text-based interface where you type commands instead of clicking buttons. Bash scripting means that you're writing small programs in the terminal to automate repetitive tasks. Things like passing log files, restarting services, cleaning up old backups. Secondly, is Python. And I want to spend a proper moment on this one because Python showed up in a huge number of cloud engineer job postings. Now, you're not expected to be a full-on software developer, but Python is the language of cloud automation. AWS has something called Boto3, which is a Python library that lets you interact with every AWS service through code. So instead of logging into the AWS console and doing something manually, you can actually write a Python script and it does it for you. If you need to automatically find and tag resources that someone forgot to label, you can use Python. If you need to build a Lambda function that triggers when a file lands in an S3 bucket, you can use Python. It's also the language behind a lot of the tooling in the cloud ecosystem. Ansible is written in Python. Most internal automation scripts at companies are written in Python. And with AI and machine learning workloads becoming a bigger part of cloud infrastructure, Python makes you significantly more versatile. And it's the bridge between cloud engineering and the AI world. And that crossover is only getting more valuable. So if you're going to invest time into one programming language as a cloud engineer, make sure that it is Python. Thirdly, PowerShell. Now, if a company runs Windows infrastructure or uses Azure heavily, PowerShell was often listed in the cloud job descriptions. This is less common than Bash and Python, but it's worth having in your toolkit for Microsoft-heavy environments. Now, the overall point here is this. You need to be comfortable in the terminal. You need to be able to SSH into a server, which just means remotely connecting to it through the command line. Troubleshoot an issue, write a script to solve a problem, and not really rely on the console UI for everything that you do. That's what separates someone who studied cloud from someone who can actually operate in it comfortably. Number 4, the core cloud services. Now, every cloud job expects you to know the core services of at least one cloud platform, and the vast majority of those job listings were for AWS, which makes sense given that AWS holds the largest market share in the cloud market. At a minimum, that's the core 4. EC2 for compute, S3 for storage, VPC for networking, and IAM for security. But it goes well beyond that. CloudWatch for monitoring and logging is how you see what's actually happening inside of your environment and get alerted when something goes wrong. Lambda for serverless compute So here you run small piece of code without managing any servers at all. You just write a function and it runs automatically when something triggers it. So it's an event-driven architecture, like a file being uploaded or user making a request. ECS for running containerized applications. DynamoDB for NoSQL databases, which are flexible databases designed for speed and scale. RDS for relational databases. So here you've got your more traditional structured databases. And understanding when to use which type is a real-world decision that you'll face constantly. And elastic load balancing, which means distributing incoming traffic across multiple servers, so not a single server gets overwhelmed. There's obviously so much more, like the AI service like Bedrock, right? And certain cloud roles require different services. But here is the thing that actually matters, right? Understanding how these services connect to each other is just as important as knowing what each one does individually. And that's called systems thinking. And that's what cloud interviewers are really testing for when they ask you to design an architecture end to end. They want to see that you can pick the right services, explain why you chose them, and describe how they all work together. Number 5, cloud security. This one is different. Cloud security wasn't just mentioned in the cloud job descriptions. It was actually often given its own dedicated section with specific expectations laid out. That tells you how seriously companies take this. So let me break it down. First, we have identity and access management. IAM is a gatekeeper of your entire cloud environment. It controls who can access what resources and what actions they are allowed to perform. The principle that you'll hear over and over again is least privilege. This means giving users and services only the exact permissions they need to do their job and nothing more. It sounds obvious, right? But getting this wrong is one of the most common causes of security breaches in the cloud. Secondly, encryption. There's 2 types of encryption that you need to know. Encryption at rest, which is protecting data when it's sitting in storage, not being used, and encryption in transit, protecting data while it's moving between services or across the internet. So you need to understand how services like KMS work. It's where you create and manage the encryption keys that lock and unlock your data. And you need to understand why encryption matters, not just technically, but from a compliance perspective. Industries like finance and healthcare have strict rules about how data must be protected. Thirdly, networking security. VPC design, subnets, route tables, security groups, NACLs. This is all about controlling the flow of traffic in your cloud environment. Which resources can talk to each other, which ones are exposed to the internet, and which ones are completely locked and isolated. Now, think of it like rooms in a building. Some rooms are public, so anyone can walk in. Some rooms need a key card, and some rooms nobody can get into without a very specific clearance. Designing this correctly from the start is what companies mean when they say security by design. And then there's compliance and governance, patching strategies, keeping your servers and software up to date with the latest security fixes, vulnerability management, so actively scanning for and addressing weaknesses, and audit logging through services like CloudTrail, which records every single action taken in your AWS account, every login, every change, every API call. If something goes wrong, you have a complete record of who did what and when they did it. Now, companies want cloud engineers who think about security from day one, not as an afterthought. Now, if there's one message here, it's this. Security is not a nice to have for cloud engineers. It's now a cornerstone skill set, which is still incredibly overlooked right now. Now, there's a few skills that just missed the top 5, but are absolutely worth knowing about. Firstly, cloud architecture and system design. A lot of cloud jobs mention the ability to design scalable, highly available, and fault-tolerant systems. Scalable means that it can handle more users as the system grows. Highly available means that it stays online even when certain parts of it fails because you've built in redundancy. And fault tolerance means when something breaks, it recovers quickly without everything going down. Now, system design is quite literally a prerequisite for cloud engineering interviews. So they'll give you a problem and they'll ask you to design the infrastructure to solve it. If you can't do that, you won't get through the interview. Secondly, AI and ML cloud workloads. More and more cloud job descriptions are starting to mention experience with AI and machine learning services. On AWS, that means things like SageMaker for training models, Bedrock for building AI-powered applications, and the growing ecosystem around AI agents. Now, obviously, you're not expected to be a data scientist or a machine learning expert, but companies want engineers who actually understand the infrastructure that AI runs on. And to me, when I think about AI infrastructure and AI workloads, the most natural role for this to be evolved into is cloud engineering, because We as cloud engineers already know how to build traditional infrastructure. Now there's a growing demand to learn about how to build AI infrastructure. So it's still the same services that we use, right? Compute, storage, networking, security, but specifically for AI workloads and their requirements. And that means GPU-backed instances, setting up the networking and security around AI services, and deploying AI models behind API endpoints so applications can actually use them. Someone else might build the model itself, right? Training that model. But you are the one making sure that it's secure, scalable, cost-effective, and has a cost-effective home to live in. This is the crossover between cloud engineering and AI infrastructure, and it's one of the fastest growing areas in the industry. You don't need to be an expert today, but if you are completely ignoring it going into 2026, 2027, then you're going to be playing catch up very soon. Thirdly, containerization and Kubernetes. Docker and containers showed up in a decent number of cloud job listings, and Kubernetes appeared in a smaller amount. Now, if you're not familiar, a container is a lightweight, portable package that bundles your application with everything that it needs to run, which means that it works the same everywhere, regardless of where you deploy it. Docker is the tool that you use to create containers. Now, Kubernetes is actually the system that manages and orchestrates them at scale. For cloud engineer roles specifically, deep Kubernetes expertise was typically reserved for senior positions or roles leaning towards DevOps or platform engineering. But understanding containerization is definitely useful. On AWS, you've got ECS for managing Docker containers without Kubernetes, and EKS for teams that want the full Kubernetes ecosystem. Both let you deploy containerized applications at scale. Fourth, monitoring and observability. So CloudWatch, Prometheus, Grafana, understanding metrics, so which means the numbers that tell you how your system is performing, logs, so detailed records of events inside of your applications and your environment, traces, the journey of a single request through different services, and alerting, so notifying you when something goes wrong. This is important stuff, but it fell just outside the core cloud skills for most cloud engineering listings. It's more heavily weighted in SRE and DevOps roles. And fifth, this is very important, being AI native. This isn't a technical skill in the traditional sense, but it's a real differentiator in 2026. Companies expect engineers to use AI tools to work faster. That means using things like GitHub Copilot, ChatGPT, or Claude to debug a broken bash script, generate a skeleton Terraform module, or break down a complex IAM policy that you can't make sense of. This isn't about replacing your skills. It's about amplifying them. Engineers who know how to prompt these tools effectively solve problems faster, learn quicker, and punch way above their weight class. And in 2026, that's increasingly what hiring managers expect from junior and mid-level candidates, the ability to adapt to new tools and new ways of working. And the engineers who use AI well are outpacing the ones who aren't. And it's as simple as that. Now look, I know there's a lot of temptation to see a list like this and think that you need to master every single one before you start applying for jobs. The truth is, in 2026, companies are looking for cloud engineers with a solid foundation across all of these skills and then deeper expertise in some. Building hands-on projects has never been more important to showcase these skills and documenting them in the right way, which demonstrates your knowledge, not just a wall of skills on your resume. That, my friend, is what's going to get you hired in 2026. And as always, I'm rooting for you. Good luck.